In plenary today. Great. So that was your first introduction for many of you of this theme of this particular forum for SciTech, Seizing the Next Digital Transformation. This particular panel is entitled Digital Transformations Disrupting Aerospace Business Models. So we're lucky to have four distinguished individuals who will talk in their respective. The digital enterprise business model is being investigated and implemented around the world and across all industries, including aerospace and defense. It is rapidly becoming the next stage of evolution for the business of making products, manufacturing products, and possibly the fourth industrial revolution. But what does this mean and how does it affect those who make things and their companies? We want to investigate that question by bringing together this group of panel of experts, the Vice President of Engineering of a highly innovative OEM, Lockheed Martin, and Sikorsky in the helicopter community, the chief engineer. I always keep giving him a new title, Andy. The program executive in NASA's Space Mission Technology Directorate, leading future innovations that affect future space missions. A vice president of tactical systems for a large defense firm, Lockheed Martin, who is working to add innovation to the system design and manufacturing process. And finally, a pioneering leader in the development of augmented reality and virtual reality technology for a host of applications. So this is who you're going to hear from in the next few minutes. But before we do that, see if this works. It's not working. If you can move the chart forward. Can you move the chart forward? Okay. How many of you took Uber to come here? Aha. So to Uber, is that a disruptive business model to you? Absolutely, right? So what made it disruptive? Well, for the first time, you used to take a taxi to come to your venue or call a taxi to go from point A to point B. Now you have your smart devices and you're able to see exactly when that person is coming to pick you up. So it gives you that sort of freedom of thought and comfort. But more importantly, the price was reduced. Why was the price reduced? Because it's a different business model. It's disruptive. It's using a digital technology. It's using GPS to locate where you are. It's using an app. And additionally, Uber doesn't own any cars. The driver owns the car. So they don't have to worry about maintenance costs like a taxi firm does. It's a disruptive business model that has happened just within the last 5 to 6 years. So the question is, what's going to happen in aerospace and defense? And that's what we want to try to tease out from our panelists to see where our whole industry is headed. But that's a perfect example of a disruptive business model that you guys are all familiar with. If you go to the next chart, please. And these are our panelists, as I just mentioned. And without further ado, I'm going to introduce our first panelist, Dr. Andreas Bernhardt. Dr. Andy Bernhardt is Chief Engineer of the CH53K program for Lockheed Martin Corporation. In this capacity, he is responsible for and provides for overall strategic leadership for technical activities of the CH53 program, including design, development, integration, and test, as well as product improvement and design development and all roadmaps. Andy serves as the principal representative to the U.S. Navy and Marine Corps, customer on technical matters, and provides management oversight to all program engineering activities and requirements, assuring that all technical program costs, engineering activities, and requirements are met. He also works with the customer in the establishment of technical key performance metrics for measuring 53K performance and progress against contract objectives. Major recent accomplishments for the 53K program include contract award for low-rate initial production, Lot 1, transition of first 2 test aircraft to Pax River for flight testing, 600 flight hours, fleet flight hours have been flown, and envelope expansion to include max gross weight of up to 88,000 pounds, and speeds in excess of 170 knots. Previously, Dr. Bernhardt was a chief engineer in the S-97 Raider program for Lockheed Martin Corporation, S-97 Raider program. In that role, he was responsible for all technical aspects spanning design, development, assembly, and testing through first flight from June 2013 to May of 2015. Before that, he served as Lockheed Martin Corporation's Director and Chief Engineer, Analytics, Technologies, and Engineering for Sikorsky's Aerospace Services. In that role, he was responsible for all aspects of aftermarket engineering, technical publication, flight and maintenance training and analytics from January 2012 to May 2013. Dr. Bernhardt graduated from the University of Maryland with a PhD in aerospace engineering. He holds 4 patents and has authored 12 peer-reviewed journal articles and over 20 conference papers. Please join me in welcoming Dr. Andreas Bernhardt.
Thank you, Dr. Pines. I should also add that Dr. Pines was one of my thesis advisors, and I still sometimes wonder if I'm going to get one more correction page to make some changes. I'm very excited to be here today to share a little bit of Sikorsky's vision of disruptive technologies, and I'll do that with 2 videos and 3 vignettes that talk a little bit about the disruption that we are experiencing right now at Sikorsky and the disruption we're providing to our customer, what we're doing in our commercial fleets, and then a little bit of a forward-looking element of what we're doing beyond that. So let me start off with the CH53K. Sikorsky Aircraft is a 90-year-old corporation. It was originally founded and incorporated under United Aircraft. They sold us a couple of years ago because we were no longer fit in their business model. And Lockheed Martin decided to pick us up because of a very, very parallel fit and alignment with their business model. But the disruption really is this. Since 1974, Sikorsky has been a Black Hawk company. That venerable aircraft that you have heard about, seen, movies, print, media, performing yeoman service around the world. Over 3,000 aircraft in every armed service in the United States, in many State Department services, fighting fires in California and operating for many air forces, navies, and armies around the world. In the 2020s, Sikorsky will generate more revenue with the CH53K than it will be with the Black Hawk. Our company is transforming. Not only are we being integrated into Lockheed, but our primary product, our most profitable product, is no longer going to be the Black Hawk, but the CH53K. And hand in hand with that, we're delivering a capability to our primary customer, the United States Marines, that is truly transformative and disruptive. In the early 2000s, the Marines determined that they needed to triple their payload capability from ship to shore, to triple it. And if that challenge wasn't enough for us, they said, oh, by the way, we're not making you any bigger ships. You have to fit that 3-fold increase in performance into the same footprint. How did we accomplish that? Since contract signing in 2006, we have developed this aircraft that is based on 4 key technologies and an underpinning of digital elements that have made this a reality. Those 4 key technologies are a 79-foot diameter rotor with best-in-class composite rotor blades, the biggest rotor blades in the world. Each of these blades generates enough lift to carry an empty Black Hawk. Each of these blades sees a centrifugal force that is as high as an entire CH53K hanging off it. Those are connected to a best-in-class split-torque transmission. This transmission has a power density 20% better than anything we've ever built. Dr. Pines worked a lot in transmissions and can appreciate the challenges and complexity of managing both the ability to put 17,900 horsepower through a transmission with a weight that still allows you to have payload in the aircraft. Those are coupled up with 3 GE38 engines. These have 7,500 shaft horsepower apiece, 60% increase in power, 60% reduction in parts. This then together is attached with a cockpit that has a 21st century glass cockpit, fly-by-wire, full authority digital engine controls, Sikorsky's most extensively integrated vehicle health management system, which I'll touch upon in a little bit. And all of this comes together in a composite fuselage that allows the Marines to carry internal and external payloads, 3-fold performance increase under hot and high conditions. If you can please run the first video. how do those digital technologies come together to do this for us? First of all, we're using CATIA V5 and LCA in such a fashion that this is Sikorsky's first paperless design. It's all model-based. There are no more drawings. Our engineering bill of materials and our manufacturing bill of materials are fully coupled and therefore provide a seamless integration to the supply chain. The drawing base is such that the technical publications and the training materials flow seamlessly from the parts. We have a collaborative design environment. When we started these trade studies in 2006, with the entire domain space open, this aircraft shares only one common element with its predecessor, and that is the shadow on the ground. Everything else is designed from ground up and brand new. That could only happen with this digital environment we did that in. Beyond that, we used advanced 21st century design tools and analysis to put this all together. So what does that mean? What that means is that we built this aircraft before we flew it. 20,000 parts, over 1,000 work instructions were assembled and tested before we even put the first parts together. The rate of engineering error per drawing was reduced by over 50% compared to historical rates. The rate of rework, for example, in 20 miles of harnesses for those harness assemblies was over 60% lower than we've had in the past. So for us, this was truly a transformative event and disrupted the way we design and build helicopters in order to deliver an aircraft to the customer in a short lead time, manageable cost, and to deliver the threefold increase in performance. As you've seen, this is a machine that will give the customers 88,000 pounds max gross takeoff weight. They can carry 36,000 pounds on that hook. And yes, Dr. Pines, when we were doing high-speed flight, we had to rent a Cessna Citation for chase because no other helicopter in our stable could keep up with it. And what we're doing with that is we're giving it to the customer at an affordable price. What they can do is mean time between flight hours has been reduced by a factor of 3. Maintenance man hours per flight hour has been reduced by a factor of 2, and mean time to repair has been reduced by a factor of 30, or by 30%. I touched earlier on this integrated vehicle health management system. Sikorsky, starting in the 2000s with the S92, made the decision to change its business model, and every helicopter we have developed since then is equipped with an integrated vehicle health management system. Essentially, a set of distributed elements, a processing unit, and a spider web of sensors across the whole helicopter. We delivered our first S92 in 2006, and ever since then, assuming the customers have agreed, we get a nightly download of their data. Over 1.1 million flight hours on 300 aircraft, over 30 terabytes of native data, and 140 terabytes of processed data. Long gone are the days when diagnostics engineers, dynamics engineers sat like shamans in a cloud-filled room in the back of the company and stared at squiggly lines of Dr. Pine's cortosis and inner-race ball energy and things like that. We can no longer afford to do that. What we have done over these past 10 years is to develop the automated tools, the data mining, the decision support technologies, such that we can allow our operators to fly longer hours with less downtime and lower maintenance costs. A couple of examples. In this intervening time, on more than 24 occasions, we have contacted one of our operators and said, you have a part that is going to need to be replaced. We recommend you schedule at your convenience maintenance in the next X hours. Think about that. In the past, the operator would fly the aircraft until either the cockpit warning system went off and said something, or you had a puddle of oil during maintenance, or in the old style of condition-based, the condition indicators, you found something had to do it. Going from reactive to pre-managed maintenance, a big game changer for our customers. Beyond that, we've all experienced in the aerospace industry fleet grounding. Something happens that you did not acknowledge or anticipate during flight test. The United States Navy had a gearbox problem, the famous cracked carrier plate, wherein they found that when they opened it up, the main element that holds the planetary pinions was cracked and grounded their fleet. At the time, we didn't have the analytic tools. A small company, Impact Technologies, figured out how to detect it if you had the right sensors on it. Well, today we do have the right sensors on it, and there have been examples in the S92 fleet where something happened and we were able to quarantine which aircraft, which components are subject to this condition, and allow all the other aircraft to fly profitably, safely, and effectively. A real game changer for Sikorsky, for our customers who can operate with a higher degree of confidence, higher availability, and for Sikorsky, who can provide these services at a higher profitability for operations. For my third element, I'd like to talk a little bit about our intelligence and automation. What you're going to see here is a video that is in 2 segments where a pilot gets into both an S-76 Sikorsky helicopter and then into a Cessna Caravan with nothing but a tablet device to control the aircraft. After the video runs, I'll give you a little bit of context on where we Sikorsky are taking the vision of unmanned flight and the next generation of flight, separate from what you have seen in the public press on electric aircraft and the small single 4-seat type of aircraft, eVelo, and all those very innovative, very exciting technologies. We have a different spin on that. Can you please run the second video? Imagine that. What we're looking at are developing and continuing to develop aircraft that have full FAA certification for manned flight, and then have the option of giving the operator, the fleet operator, the battalion commander, the ability to fly the aircraft with 1 crew member, no crew members, or to simply fly the machine with a mission operator. A scenario, to give you an example. Battlefield in a place where none of us would ever like to be. The commander has 10 Black Hawks at his disposal. For whatever reasons, he doesn't have enough crews, and he needs to run 2 missions. He needs to deploy a autonomous set of vehicles to a place to go and do investigation, whatever they need to do with that, and he needs to go and drop supplies to some people who need it. And he doesn't have enough pilots. He may have 1 pilot who can go and fly the toughest decision-making mission, and for the others, he can have a guy with a tablet sitting in his tent or sitting stateside, start the mission, fly it from point A to point B, pick up the loads, drop the supplies, and as we've demonstrated, for example, here in West Palm Beach, pick up a linked autonomous vehicle, let the autonomous vehicle and the aircraft talk as to where they need to go land it, drop that vehicle, in this case it was in the swamps behind our flight test facility, let that vehicle go and do its mission, fully autonomous, and then when the mission is complete, in this case a couple of days later, get the call, come and pick that vehicle up and bring it back to its home base. So Sikorsky's vision here is to really change how we look at deploying aircraft and provide decision-making assistance to the pilots, the operators, and give the fleet commander the opportunity to either have pilots in the loop, mission operators in the loop, or in the grand sense, strategic operations where all these aircraft can be deployed semi-autonomously. The last thing I'll share with you is a little bit in the area of artificial intelligence, we have two interesting initiatives going on, amongst others, but the first one of them is decision-making. Today's warfighter is inundated with a variable barrage of information. He has to aviate, communicate, navigate. He has sensors from LiDAR to radar to weapons technologies, and he, at any given point in time, has 1,000 rocks to look under. The human brain is a serial processor. We can only do one thing at a time. There's some great Mythbusters episodes out there where people have claimed they can multitask, are proven time and time again that they can't. And so we have this human bias in decision-making. If we let artificial intelligence do the right unsupervised, unstructured learning to help you with that decision-making and identify the 10 rocks that you really need to look under to effectively execute the mission with lethality, survivability, and effectiveness, that's a game changer. And then the last one I'll share with you in this context, which I think is an unusual one, but for our company very, very interesting. You look at large corporations like UTC or Lockheed Martin, thousands of employees, thousands of patents, thousands of technologies, very, very broad interests. And time again, we discover that in our little stovepipe fiefdoms, we try and reinvent the same trade secrets, the same patent applications, because try as we might, we really are not very good at integrating across large domains. And we have a couple of research projects where we're looking at how do we enhance the connectivity across Lockheed Martin Corporation? How do we ensure that people with certain skill sets, certain technical areas of expertise, certain interests, certain projects are connected with, aware of, and provide a productive, collaborative workspace environment that transcends traditional stovepipe boundaries. In that sense, I'm actually very happy to meet a Lockheed colleague here. We'll have to exchange some notes on breaking down some of those boundaries. So from my perspective, a couple of thoughts on digital technologies that I had work at Sikorsky and our large integration with Lockheed Martin. Thank you very much for your time.
So I forgot to say that what we're going to do is have each of the panelists speak for about 15 minutes, and then at the end of all the presentations, we're going to have the a question and answer period. So next up is, thank you, Dr. Bernhardt. Next up is Dr. Lenitra Tate, who joined NASA Kennedy Space Flight Center in October of 2005, where she worked in the polymer chemistry and material science groups, focusing on composites and nanocomposites. Dr. Tate currently works at NASA's headquarters within the Space Technology Mission Directorate as a program executive for the Game-Changing Development Program. Prior to this role, Dr. Tate served as the STMD, Advanced Manufacturing and Nanotechnology Principal Technologist, and the NASA representative to the National Manufacturing Initiative, where she interacted with other government agencies, including the National Institute of Standards and Testing, Office of Science and Technology and Policy, and National Economic Council. Prior to being principal technologist, she served as the composites lead in the material science division at Kennedy, as well as the composites repair lead on multi-center efforts of composites for exploration and composite cryotank projects. Dr. Tate completed a temporary assignment at NASA's Marshall Space Flight Center in Huntsville, Alabama, in support of the Advanced Composites Technologies Project, where she worked composite manufacturing and repair processes. Dr. Tate has received numerous awards, including the 2016 NASA Commercial Invention of the Year Award and the 2014 R&D 100 Award, both for work done at the Kennedy Space Flight Center in the area of color-changing materials and hydrogen detection. Dr. Tate also received the Exceptional Performance Award from NASA headquarters in 2015. Dr. Tate was profiled on the cover of USF magazine, Nanotechnology: Take a Look at the Power of Small, for her work in carbon nanotube-based composites. Dr. Tate holds 7 patents, 3 published patent applications, and has been published 19 times. Dr. Tate received her undergraduate degree from Florida A&M University and her doctoral degree in chemistry from the University of South Florida. Please welcome Dr. Tate.
Thank you, Dr. Pines. As Dr. Pines says, I'm Lenitra Tate from NASA Space Technology Mission Directorate. Space Technology Mission Directorate is one of 4 mission directorates at NASA. We are responsible for investments and maturing cross-cutting technology across the TRL technology readiness level, from TRL 0, that concept that you write on the napkin, all the way to flight demonstration. The Game-Changing Development Program is one of 9 programs within the Space Technology Development, Space Technology Mission Directorate. And we are the mid-TRL program that seeks to mature and develop technology that's high risk, high reward, high payoff. And we do this by partnering with industry, other government agencies, and academia. We really strive to mature technologies so that they are transition ready to hand off to either another mission directorate that's ready to infuse it into a mission, or another program or industry to mature it further and to develop it further. So when Dr. Pines contacted me about being on this panel, I had to think a little bit because NASA has so many disruptive technologies. We are a very unique organization because space is a stringent environment, and we have to have very tight requirements to achieve our mission goals. And so I looked through our portfolio and thought that the most disruptive technologies that we're working on right now within the Game-Changing Development Program and Space Technology Mission Directorate is our spaceflight computing, our free-flying robots, and believe it or not, we've really worked to spearhead technology management or configuration control of how we access our data, programmatic and technical. And so I'll talk a little bit about those. And another thing that NASA has really focused on over the last couple of years, and Space Technology Mission Directorate, is how we utilize social media and web-based platforms to engage with the public and to really disseminate our technology advancements to the public. So, transforming space computing. Everyone's familiar with high-performance computing, but spaceflight computing has not kept up with the needs of NASA and DoD as far as what we need to do to travel deeper into space, to do potential autonomous surface operations or precision landing and hazard avoidance. So we haven't kept up with the state of the art hasn't kept up with those needs. So NASA, in partnership, Space Technology Mission Directorate, in partnership with our Science Mission Directorate, as well as the Department of Defense, we're investing in a next generation high-performance spaceflight computing. So this will, once matured, fully matured, will provide us 100 times performance increase over the RAD 750. We will be able to scale this up to 15 giga operations per second, as well as up to 10 watts of power. We're partnering with Boeing, St. Louis, with Boeing St. Louis, to develop a multi-core processor, and we call these chiplets. And not only will these chiplets provide us greater performance and scalability, but it'll also provide us radiation-hardened prototypes. And so it's almost like if we build it, the missions will come. Everything from autonomous operations, robotics, DoD applications. And so this is one of our highest priorities of enabling a new class of space computation. This is being led out of our Jet Propulsion Laboratory, as well as Goddard, and as I said, DoD and Boeing. Transforming space robotics. Now, gentleman here brought a video, and I should have brought a video because the project team loves to use the video of Luke Skywalker. I think it's in the Empire Strikes Back, and the lightsaber training, and you have this free-flying droid training Luke on how to wave his lightsaber. So this is essentially a free-flying robot that we would use on the space station. The key about our free-flying robot, or Astrobee as we call it, is that not only will it be used to assist the astronauts in doing routine tasks like inventory. It'll have an RFID scanner, and it can maneuver through the space station and help them understand or take inventory. I see Pam smiling at me over there. And so this will be able to do that. As you know, our astronauts' time on the space station is valuable. So to be able to have automated astronaut assistants on the space station to help them do some of those routine tasks is very vital. But the key of what we're doing here with Astrobee is that it will be open source software. So not only will our controllers or our engineers at Johnson be able to control the free flyer, but citizen scientists, engineers, scientists external to NASA will be able to use user interface code and improve upon or use this as a test platform for some of their tests and demonstrations that they would like to conduct in zero-G. So we're improving upon what we already have on the space station, which is spheres, and we're adding more capabilities to help do mundane tasks as well as open source software. We're also tapping into the smartphone industry and using several off-the-shelf components from the smartphone industry. So another critical aspect that we're working on is EDL, Entry, Descent, and Landing. Space Technology Mission Directorate has the key responsibility within NASA to invest and mature entry, descent, and landing technologies. Modeling and simulation is critical to that. You can't just buy down risk for these EDL technologies by doing ground-based testing. We have to buy down some of the risk and do some of this risk reduction activities by modeling and simulation. So we have a separate project called Entry Systems Modeling that work with each EDL project, be it Medley 2 or DEPT, which is a deployable heat shield, or our HEAT project, and actually taking their challenges and modeling them to help buy down some of the risk. And in doing some of this computationally intense modeling, we will need spaceflight computing. I know with one of our EDL projects, they're actually working with HPSC to eventually find the synergy and apply that to what they need for EDL applications. Now, EDL is not just, it extends beyond NASA, but NASA has very unique requirements, and we have very unique EDL challenges and problems, and so we have to make sure that this is a focus. And so we've done a lot of great work in this area to the point where many of our risk reduction simulations and models have infused into Mars 2020, OSIRIS-REx, InSight. And so we've actually seen it from computational modeling to actually being used by a mission. So GCD, for any given year, has over 30 projects and over 50 technologies that we manage. And historically, we have input data manually, and that can cause errors, and it can be very time-consuming. So what the team did is said, hey, how can we automate how we control our data, configuration control, how we access our data. At any given time, we have many stakeholders coming to us, hey, we need this, how many FTEs do we have here, how much are we spending on here? So our project team took traditional platforms with new web-based platforms and gaming technology to develop what we call our business automation tool. And this took over 2 years to actually get to the point where I can sit on my iPad and pull up a project and say, how much have I spent on this project? Or I can say, how much FTEs are at this center? So it's a very interactive tool that I can use on my desktop, or I can use on my iPhone or my iPad. Another beauty of this is we had a summer student last summer come on board and work with the team and actually link this and interface it with Alexa. We call her Ava. And so I could be sitting at my desk and I could say, Ava, what are we doing in FY19 regarding dollars for high-performance spaceflight computing? And she will tell me. So we've been able to do this interactive tool to allow us to manage our data better. I mean, if you think about the amount of dollars, the amount of information that we have to keep track of, and having either a big booklet or going through a SharePoint isn't necessarily efficient, but this is more efficient. We can also eventually, if we so choose to, link technical data to this. We can actually do a test on compression testing on samples and actually link that data, and we can go to Ava and say, hey, Ava, what were the results of test A for this specimen? So this is one way that we've used cloud-based computing and gaming technology to help transform how we manage our technology. And the last thing I want to talk about is social media. We've done a really good job of trying to get awareness of many of our great technologies out to the public. We've had Facebook Lives. We've done Twitter chats with the Hidden Figures. We've also been able to real time and interact with the public, show what we're doing on an International Space Station. We sent our phase change heat exchanger to the space station. We were able to, in real time, show the testing of that system. And so NASA as a whole has really embraced the fact that we need to make sure that the public understands what we're doing as far as our technology investments and our technology development. And so we've really made an effort to go to like Bally Ribbon Mills, which is a small textile company who's now developing heat shields, 3D woven composite material for our entry, descent, landing capabilities and technologies, and doing a Facebook Live with them. Or we've really had the forethought of sitting down with all of our mission directorates and tapping into middle schoolers and having a tweet chat on what's the latest and greatest at NASA. So these are things that we're doing to disrupt technology and disrupt the digital landscape. They may seem in and by itself like, oh, well, that's just spaceflight computing. But when you look at it as a whole, we're really trying to push the envelope and meet the needs of NASA, meet the needs of industry, meet the needs of the citizen scientist, and really understand that technology does drive exploration, and that we do more in partnership, and we do more with collaboration, and we do more with communicating and getting the word out to the external community so that we can continue to accelerate our technology and the needs that we need to explore deeper into space. So with that, thank you very much.
Thank you, Dr. Tate. Our third speaker in this panel discussion is Mr. Jack O'Banion. He was Vice President of Strategy and Customer Requirements for Advanced Development Programs at Lockheed Martin, also commonly known as the Skunk Works. In this capacity, Mr. O'Banion is responsible for engagement with DoD customers to understand the operational challenges they face throughout the battle space and the identification of innovative solutions to address those challenges. Mr. O'Banion's duties include alignment of ADP's vision and strategy with current and emerging customer requirements, identification of the necessary technology investments to meet those requirements, and formulation of new product initiatives at ADP. Mr. O'Banion's work at the Skunk Works includes projects ranging from new air dominance and strike platforms and capabilities to C4ISR platforms. He's also been involved with next-generation air mobility aircraft, advanced unmanned aerial systems, and autonomy and human-machine teaming, including hypersonics, directed energy, and advanced power generation solutions such as compact fusion. Mr. O'Banion's efforts include enhancements to current weapon systems to enhance their effectiveness and maintain their relevance in the face of rapidly changing operational needs. Prior to his current role, Mr. O'Banion served as the director of the Air Mobility Improvements and Derivatives team for ADP, where he was responsible for providing a new capability solution for the C-130, C-5, P-3, and S-3 aircraft. Mr. O'Banion also served as the director of C-130 Special Mission Programs, where he was responsible for development, production, fielding, and sustainment of the Air Force Special Operations Command's new MC-130J Combat Commando II Special Operations aircraft, Air Combat Command's new HC-130J Combat King II Search and Rescue aircraft, initiation of the AC-130J Ghost Rider gunship program. He graduated from the University of Texas and receiving a Bachelor of Science degree in Aerospace Engineering with honors, and graduated from Emory University receiving a Master's of Business Administration degree and the Most Outstanding Academic Achievement Award. Please join me in welcoming Mr. Jack O'Banion.
Dr. Pines, thank you very much. Good afternoon, everyone. It's a pleasure to get to brief you today. I wanted to start off talking a little bit about how disruptive technologies have been a key component in what's been going on in the Skunk Works for quite some time. So let's go ahead and start off taking a little look at where we've come from. You may have heard of the Skunk Works before. That term has appeared in academia quite a lot in terms of ways of creating innovative approaches to creating new solutions. But the original Skunk Works does come from Lockheed Martin itself. In fact, this is our 75th anniversary this year. What I'd like to talk a little bit about is how disruptive technologies have been key to creating that ongoing track record of success, and then how it plays now both into our design process and into the designs that we're producing using those processes. Let me go ahead and start off also by emphasizing that a key component of what sets the Skunk Works aside is not only creating disruptive, innovative designs, it's doing so rapidly, being able to create something in a short amount of time that is a rapid and significant departure from an existing paradigm. So I want to weave those three elements into our talk here. But to give you a little bit of background of where we began, we rose out of a national requirement. The challenge the nation faced at the time was in 1943, our bomber formations over Europe were being ripped up by a disruptive design we faced for the first time. It was the Germans' Messerschmitt Me-262, the first operational jet fighter to see real combat in a major theater. It was 100 miles per hour faster than anything we could throw at it. We had very great difficulty countering it, and it was taking huge tolls on our formations. So as a result, one of our founding fathers, Kelly Johnson, advanced designer at Lockheed Martin, went forward to the Army Air Corps and said that in 180 days we could produce an aircraft that could take on the Me-262 and change the balance of power in the air. The Air Corps took him on that. He went back out to Burbank, announced to our president at the time, Hal Hibbard, that we had this great new contract to produce the first operational jet fighter, to which our president said, "Great work, Kelly. You might have noticed, though, the factory's completely full of B-20, B-24, or rather B-17s and P-38s. There's no room here to build your airplane. You signed the contract, you figure it out." So Kelly went and hired a circus tent, erected it in the parking lot, took a small set of highly skilled engineers and artisans from the production line, and in 143 days, flew the XP-80, America's first operational jet fighter, well ahead of the commitment of 180 days. And in doing that, he formed a process, an approach to design that has been the key DNA for how the Skunk Works has functioned ever since. Basically, what he formulated were 14 key rules, and you can find these online. You go ahead and give me the next slide there, please. Basically, what he found is that if you put a small team of engineers together, you gave them a very intimate and close relationship with their customer, you empowered those teams to work together in an environment of high trust, they could move far faster than large encumbered organizations could. He also realized they needed a very flexible set of design tools to enable them to move fast, to make changes quickly, to adapt rapidly in order to meet the cardinal requirements of the project. And that was another key formula that he used. Very narrowly drawn set of requirements with an objective of one major miracle per project. And in that way, the design team had the opportunity on the fly, day by day, working with the customer to make trades as they went to achieve that cardinal subset of requirements that were the key objective of that project. Flexibility in cost controls and a significant amount of reign granted by management to be able to operate in this level of autonomy were also keys to making it happen. But the results were pretty impressive. If you look at how that model's been applied over time, it's enabled the Skunk Works over and over again to disrupt existing paradigms of design and create something fundamentally different. Whether it was an aircraft that for the first time could routinely operate above 70,000 feet, or the first stealthy design for an aircraft, the SR-71, that not only employed stealth for the first time, but could operate over 80,000 feet and well above Mach 3, those are significant breaks in traditional paradigms and capabilities that would not have happened without a significant departure from standard approach. The F-117, the first stealthy aircraft sufficiently stealthy to be able to operate in an integrated air defense grid with impunity. And by the way, just to give you an idea of how successful these were, the SR-71 operated for 24 years, had over 1,000 missile engagements against it, never once engaged successfully by an adversary. The F-117 opened the war in Iraq. 40% of all targets engaged in Iraq were engaged by 117s, despite them representing only 1% of all coalition combat aircraft. And when it engaged a target, it had a 75% direct hit rate, and that was its first major operational use. These products were also created quite rapidly. If you look at the amounts of times to produce them, the first U-2 from contract award to first flight, 8 months. The SR-71, which required all new materials, first aircraft out of titanium, first application of stealth, and the first application of a coaxial hybrid propulsion system that combined a turbojet with a ramjet, flew in 32 months. 117, 31 months. Radically different designs produced in radically short periods of time to create a game-changing capability. Then if you look at the current state-of-the-art in combat air, whether it's the YF-22, which we produced in 48 months, or the X-35, these were game-changing designs in themselves. Integrated avionics to allow them to machine collaborate with each other, engaging a target. First time that we've applied stealth to tactical aircraft. The ability to supercruise without afterburner. In the case of the X-35, first time we took an aircraft like that and made it take off and land vertically and come off on and off an aircraft carrier. Totally different departures from what we're able to do before, done in a short amount of time, by consistently applying those rules of innovation that formed the Skunk Works itself. So now the question is, where do we go from here? We've always been driven by what's happening in the environment and what's happening with the threat. The threat has been watching that process also. They've been watching how America engages. They've seen us in continuous combat now for over 20 years, and they've been modeling that. And now coming back at us with a significant rate of innovation and a significant rate of change, far faster than what we've seen before. That creates a driving function on what we need to be able to do in design. It's disruptive to us, and we have to stay ahead of that curve. Staying ahead of that manifests in terms of speed. And it's speed in 3 key dimensions. First is the ability to assimilate what's happening, assimilate the data around you, and be able to arrive at a decision of what to do. From that decision of what to do, how fast can you create an effect from that? Whether it's either designing and fielding a design that answers what you've decided to do, or creating an effect in a battle space. So what I'm saying here is that these 3 items I'm walking through apply equally to whether we're talking about operating a business and designing and producing a product, in this case, a combat aircraft, or if we're waging a campaign in the battle space and we're trying to create effects in the battle space. All 3 steps apply. The third is the speed to adapt. So assimilating the data, arriving at a decision, progressing from decision to creating an effect, and then realizing your adversary is watching what you're doing and adapting what they're doing. Can you adapt faster? If you're able to tick the boxes on all 3, you win. So let's take a look at what the ramifications are for these if we apply them to first the design process, and then we'll apply them to what happens in our designs going forward. Anybody recognize this image? Very popular movie, Iron Man. Tony Stark had one heck of a design process. If you had an opportunity to watch Iron Man, you saw a designer essentially in heaven, being able to do whatever the designer wanted and have real-time feedback about what each decision was making on the product. So we talked a little bit about some of the design tools here where, in the case of Sikorsky, we're essentially creating a digital thread for the product that can play through multiple disciplines so that each successive discipline is building off the same data understanding of what the aircraft is, so that we're able to play it through to manufacturing, onto training, and onto other elements of the design. We also talked about at NASA what we're doing now to open up access to data so that we're able to mine what's been out there before us and take advantage of what might be happening ahead of us. But we want to then look at what goes beyond those steps. What more can we do from there? So as we go into the idea of advanced design synthesis, we'd like the ability to be able to interact with our design, and certainly some of the tools coming from Oculus give us the opportunity to do some very advanced visualization techniques and manipulations of the design, which is great as the beginning designer, being able to rough out what I think I want this design to do. But then there's some things I would really like to be able to have available to me from there. In the Iron Man example, we had a situation where I could interact with an intelligent agent that could give me feedback about what effect I was having on my design as I went. What would happen if I changed this? How would the performance alter if I did that? Now I'm able to get real-time feedback about what I'm doing. And having essentially a Siri for designers that can, one, locate data for me, but then also begin to give me performance feedback about what effect I'm having on the design would be a huge step forward for that. And also the ability to do rapid lookup of information that may not be immediately obvious, like what are the B-base allowables for this material if I changed this material? What effect would that have on the end performance or structural integrity of the design I have? If I alter the pressure changer of this motor in this way and alter it so that I can fit around this object, how have I affected the overall performance of that motor? If I created a hotspot that exceeds the thermal allowables for the particular sidewall material that I've selected here. And then from there, I would like for that intelligent agent to be able to augment my ability as a human. Not doing what I do, I want to be the creative element there, but I want them to collaborate in the unique ways that a machine can collaborate with a human. I'd like for them to check for things I might have missed. Hey, are you aware that when you did that, you created this issue that is now going to require you to bump your material selection off of what you thought you had? Or another interference issue that I might have missed. And then I'd like to have optimization available to me in real time so that I'm able to go through and say, now, if I change this wing in this way, is it going to give me my range objective that I want to have? Please optimize that for me. Now, there are optimizing routines out there now, but if you're not careful with the human too far removed from the design loop, you can walk through design choices that you would have preferred to make, but because the optimizer didn't know it was of interest to you, it drove right past it. So let's say I had a design here where I really needed to make a 3,000-mile range. And the optimizer optimized the airplane out to give me exactly 3,000-mile range for the least structural weight of the airplane. But it didn't tell me that if I had made a slight change in how I optimized that wing, I could have reduced the takeoff performance by 1,000 feet. If I had been in the loop, I would have seen that sensitivity and I would have been very interested in that. I might want to change 5 miles of range for 1,000 feet of takeoff distance. I would like my cognitive assistant to know how relevant that is and point it out to me that, hey, are you aware you could trade 5 miles here for 1,000 feet of takeoff performance? And then I would like the ability to cross-domain design so that I could say, well, that's a very interesting idea. What would that buy me? I'd like for you to take this design, put it in the operational scenario we're designing for, and give me feedback about how it performs in the mission. And if it comes back and tells me, you know, what that does is it opens up 80 new airfields closer to the objective you couldn't previously use, and as a result, you're able to win the war a week earlier. That's very relevant information to have back. I'd like to also know what the producibility assessment is. Did you know if you narrowed this bulkhead by 1 inch, it would fall to a standard ingot size that would reduce the cost of that ingot by 70% over what it's going to cost as you currently laid it out? Would I like to know that at the moment I laid down the lines for the airplane? Absolutely. I wouldn't want to find that 6 months later in the design process and have to go back out a lot of work because the cost of change is far lower where I am now than when I go that far into the design process. What about supply chain? If I'm designing around a particular warbulator in the left hip of the Iron Man suit here that I know can do the job because I'm familiar with it from last year, what I like for the supply chain to immediately flag that of, did you know the company making that part now is in a red financial condition? Well, that means by the time we run the competition and run supply chain, we're going to find that out 4 months later, and I'm going to have to go back and redesign this part. I would like to know that now. And then lastly, what is the ultimate impact to sustainability? Can you do me an assessment about whether I've located these components well? Yeah, well, you picked one here that you didn't put in a high access compartment, that's likely to be manipulated by a maintainer about 4 times a year. You probably ought to relocate that part so it's more accessible. Those are all interactions that an intelligent agent could potentially aid me as a designer in moving faster to a design that doesn't require expensive alteration downstream and can be fielded as an operational capability sooner. Now, what about the designs that are being produced themselves? The digital transformation is having a very dramatic effect on these designs. So I'm going to start off with the fighter aircraft. One of the most important things that's happening here, certainly there are advances going on in range, speed, weapons, payload, signature, but the digital transformation is fundamentally changing that design as well. There's a transformation called the combat cloud that is emerging out there. And this is beginning to link things together in the basically in the same dimension as the Internet of Things, but in the combat space, so that I'm able to know what that satellite over my head knows versus that information going to some intelligence agency in the rear. I've got it in the cockpit. I'm able to be aware of what other aircraft around me know in a much deeper and richer way than I've been able to know it before. That's being assimilated for me in a combat cloud that doesn't require all the processing to happen on my own platform and from my own sensors. I can get contextual information from what others know around me. That may become relevant to me based on what I am doing. And I have an intelligent enough assistant to know, hey, if you're now thinking of heading over there, I better make you aware of some things that you didn't get in your mission brief, but now that I see your intent is to go there, I'm going to make sure that you're aware there's some information you should draw on, or that you may wish to draw on. Think of Google Maps as you go driving about, letting you know that as you change your route, there's certain ramifications dynamically that you should be aware of. That takes a secure comms capability. It takes high bandwidth on data links. It takes a lot of processing power on board the aircraft. And because the battle space is extending into the digital domain, it means the weapons array of this aircraft is also going to extend into the digital domain. We're going to begin seeing cyber warfare. We're going to begin seeing network-on-network warfare. And this is just another node that's going to be part and a contributor to that battle space. All of that has significant ramifications to the amount of power cooling capability on board the aircraft. So where we used to have design constraints driven largely by aerodynamics, signature, and performance, now we're beginning to see designs that are being shaped by the amount of power and cooling they have to be able to generate in order to survive and create the effects necessary in the battle space. Really creating some significant differences in terms of what these aircraft look like compared to their predecessors. And lastly, I want to talk a little bit about the digital twin idea. This aircraft will have with it a digital twin. If I do mission planning that says I want to take aircraft A, B, and C, and I want to send them off to go to do this mission, the digital twin that knows every part on the aircraft, the condition of the parts on those aircraft, the limitations, and the scheduled maintenance elements of the components on that aircraft may say, if you deploy aircraft A, you're likely to have it in the field based on historical standards for about 3 weeks doing that mission. It's coming up for a maintenance interval that will likely require it to be down in the back end of that 3rd week. Oh, by the way, 80% of the time the 3rd week becomes 4, that'll make it a certainty. But if you pick aircraft D, all 3 aircraft are likely to be operational and in good shape for the intended mission, plus the likely extension that we often see in these kinds of missions. Those are things that the digital twin can deliver if I create it as I put the aircraft together and then maintain it as it goes through operational use. Next aircraft next to it is hypersonics. Talk about speed, you're talking about hypersonics. What we mean by hypersonics are aircraft that routinely operate above Mach 5. Their intention is to attack that part of the timeline I mentioned earlier of from decision to effect. Can I make it happen faster than an adversary, and can I do it in such a way that an adversary can't counter so that I can hand the warfighter an effective deterrent? Without the digital transformation, the aircraft you see there could not have been made. In fact, 5 years ago, it could not have been made. And one of the major enablers that's come out of digital transformation is the ability to have the processing power and the tools sufficient to be able to design that scramjet engine in 3 dimensions so that we have robust enough performance for it to be able to operate with agility at hypersonic speed, with heavy maneuver, with heavy agility and speed, and not have an unstart of the inlet, and to be able to have reliable start and unstart of the inlet when we want it, of the engine itself. We couldn't have made the engine itself. It would have melted down into slag if we tried to produce it 5 years ago. But now we can digitally print that engine with an incredibly sophisticated cooling system integral into the material of the engine itself and have that engine survive for multiple firings for routine operation, and there are no moving parts involved. Could not have even built it, even if we conceived of it, without digital transformation and the added manufacturing techniques that we have now. Lastly, I'll talk about the unmanned aerial systems, which bring up some very interesting topics. And I was speaking with a young woman earlier who was working in robotics out of Duke. This intersects here very well. Here we're talking about autonomous systems with variable human interaction. How much autonomy do I want? Depends on what I'm doing that day. I want to be able to scale it up or scale it down depending on what I'm asking of it. This is one of the things Sikorsky is working on too with the 210 initiative, to be able to scale how many humans are on board the helicopter based on what I'm asking it to do today. Man-machine teaming between UASs and manned aircraft is also important in this construct. I may want to have a manned aircraft in the environment, but I may want it interacting with 4 UASs to create collaborative effects using those covert data links that I mentioned earlier. That means I need enough smarts on board the UAS to realize when it's in contact with its human and when it's not, what it's authorized to do and what it's not authorized to do without checking in with the human, and to make reasonable choices about it, what it does, with or without the human interaction from one moment to the next, because after all these data links are constantly under attack by our adversary, who's attempting to disrupt them or to insert spoofed data onto them. And I need to be smart enough to be able to know which one I'm dealing with there. Ultimately, all of these aircraft have to adapt quickly to the changing environment they're fighting in. That leads us to open architectures and how we create their mission systems. So all of these will have open architecture systems that allow them to be able to adapt rapidly, to be changed quickly, to address a changing environment. So to wrap up, disruption has always been key to our business model. It has been an essential element of how we've innovated. The digital transformation is yet a new axis that we're now taking advantage of to be able to design more rapidly and to create game-changing aircraft. But I would point out that in the end, those are only tools. They're only as good as the talent that wields them. And so I would ask, and I know that we've got some representatives here from Buffalo, as well as Duke and other universities here, if you are interested in being part of the best, we're interested in that talent. We would love to have you come and work with us, be it Sikorsky or in the Skunk Works, and help make some of these transformational capabilities a reality. So thank you very much. Appreciate it.
Great job, Jack. Thank you very much. Our fourth and final speaker deserves minimal introduction. He is the co-founder of Oculus and a vice president who oversees engineering and product development for all of the Oculus products, including the Rift. He's also attended University of Maryland, and we're very proud to have him as part of the University of Maryland family. Please welcome Mr. Brendan E. Reed.
Thank you. Good afternoon. So I thought I'd do something a little different, and instead of diving into our current products, I'd paint a little vision of the future and where we're going, where I at least believe the world is going. How many of you have used an Oculus Rift? Okay, good, a few people. Well, if you have, then you've experienced the sense of presence. And that's when you put on the headset and suddenly you put on this ski goggle. For those of you who haven't used it, you put on the ski goggle and suddenly you're teleported to a new dimension, a virtual dimension, and you believe that you're actually present there. And that is the beginning of the virtual age. And what I mean by the virtual age is the beginning of where humans and computers finally intersect. And instead of us using computers as tools, we start augmenting ourselves. We start augmenting our vision and our perceptual system, and we start living in a world where we're spending more and more time in a mixed reality. And I believe that the virtual age is actually going to be as important or even more important than the information age, the computer age, and all of the different technologies that we've seen to date. I think this is the next great leap, and we're at the very, very beginning of it. So I thought I'd start with a little story. This is Paul Reed. This is my grandfather, and he was an aerospace and aeronautics engineer. Unfortunately, he died before I was born. So my mom loves to tell these stories about him, about Daddy, her dad, how funny he was and how interesting he was, the stories he had about aerospace and what he was really excited about and where the world was going back in the 50s and 60s and 70s. But then he passed away. He had a heart attack, and I never got to meet him. And I'm sure many of you have relatives, grandparents, or great-grandparents that you've heard about, but you never got to meet. And all that we have is a few black and white photos. What if that changes? What if we can actually keep people alive? What if we can keep them alive in a virtual form? I believe we can, and I believe that that is where the virtual age will eventually go. So, back to the beginning. Right now, we're at the first generation of VR, and it's all about this sense of presence that I just described. The next step is going to be self-presence. Today, when you put the headset on, you look around, you feel like you're there, your vision system is tricked. In your brain, there's a switch that kind of flips, and suddenly you believe you're there. You look around, you see your hands, floating hands right now, but when you look down, you don't see your body. And so your brain starts to remember and realize, wait a second, I'm not actually fully here. And that sense of presence can start to break down. So I think the next step will be getting your full body in. We need to put the headset on, look around, and sure enough, look down, see ourselves, see our arms, see our fingers, be able to manipulate the objects in the virtual world with our fingers, be able to navigate and move around. It's very hard to move around in a virtual world unless you can actually see your legs and your feet so you can navigate and know how not to bump into things. After we get self-presence, which I think we're very close to, I think we'll be heading towards social presence. So once we are all in, our whole body, we now want to get other people in with us. And we want to get those other people in a way that we really believe they're right there with us. So imagine you put on this headset, and sure enough, you see somebody that you know that could be hundreds of miles away that appears right in front of you, and your brain believes they're there. We call that social presence. And that is going to be one of the biggest breakthroughs and kind of in many ways, the holy grail for VR to go to billions of people is going to be as a communications device. Think of the telephone bringing us audibly all together in one device. And now you have this pair of glasses you can put on that brings us face-to-face visually in one device. And I believe that that will really take VR and the virtual age to the next level. Suddenly, we're all together in this world. At any moment, we can teleport right together and see each other. Now, once we start wearing these glasses, I think we're going to be scanning in the world as fast as we can, because we don't want to just jump to a virtual place made by artists. We want to jump to a real place. We want to put on the glasses, and maybe, I know my best friends all live in New York, many of them live in New York from college, and I only get to see them a couple times a year. Well, I'd love to be able to go to lunch with them multiple times a week and actually experience for 30, 60 minutes, experience their presence with me, all of us together eating, maybe in Times Square, or maybe we teleport over to India or somewhere else in the world. And to do that, we have to start scanning in the world. And I think you'll start to see these VR and AR headsets will start to add more and more sensors where they're both scanning in ourselves as we're looking around and needing to see ourselves and see other people, but we're also starting to scan in the real world and create a persistent model of the real world. If you think of Google Earth and Google Maps has created this kind of two-dimensional, starting to add some 3D, but fairly low resolution in terms of satellite imagery of the world. We want to create a persistent 3D model with incredibly high detail of the entire Earth. So once we get that persistent model and we've started to scan in lots of the Earth, we can start teleporting around to different places. It'll start with rooms and some special destinations, maybe museums and the Mayan ruins and temples and different wonders of the world. But eventually, as we start wearing our glasses more and more daily, many hours a day, maybe all day long, we'll start scanning in the whole world, and we'll be able to teleport anywhere we want to go. So now we'll have self-presence, social presence, the ability to be face-to-face, and we'll have teleportation, where we can jump and go to any different location. So, back to Pauly Reeb, my grandfather. How do we get Pauly Reeb in there? Well, I believe that if you look over the next few decades, and this is not going to happen right away, but it's going to take a while, but it will happen eventually, as we are wearing these glasses more and more, and we get to a point where we're wearing smart glasses every day, all day long, because they're giving us these incredible superpowers, I believe that we'll start to build a database not only of Earth, but we'll build a database of people. And these glasses will have sensors in them that are looking back at your face, at your own face. They're tracking your eyes, they're tracking your mouth and your facial expressions, they're tracking your body movement, and we can start to build a database of humans. And as that database evolves and as it gets more and more data and it gets daily data, I believe that we'll be able to create virtual humans. And virtual humans will be this set of data that pulls together all of your expressions over a period of time that can then create a virtual avatar that is very, very similar to you. Now, maybe your loved one or somebody that you know well won't want to talk to the virtual version of you because they know the real version of you, and this doesn't really feel like the real version. It'll take a while to get to that kind of authenticity. But I believe for all of us who never got to meet someone like my grandfather, who I never got to meet, instead of just a black and white photo or a colored photo or even a video, I would love to be able to sit down and talk to him and ask him questions. And if it felt like a real person, maybe not exactly like the real version of Paul, but I never knew the real version of Paul, I believe we will start having these virtual humans saved and captured in a way that we can communicate with and that live on for a very long time. And we can have them of famous people, of important people in the world, and family members. So there'll be a lot of questions around how do you share this data, how do you store this data, the privacy around this data. There's a ton of things that we have to tackle for this to all come true. But I believe we are on this path, and this is going to be the virtual age where we get everything from face-to-face communication, telepresence, and teleportation. We'll even tap into time travel as we start mapping this persistent world over time, and eventually we'll get to full virtual humans. And we'll live in this world where we can talk to anybody at any time or go any place, all in a pair of glasses. And it won't just be Earth that we're mapping. You guys are getting us to space. And I know there are a number of really incredible, brilliant minds and some very well-known entrepreneurs that are trying to take us out to Mars and to colonize Mars. I believe that we can get to Mars with spaceships and rovers much sooner than we can get there with humans and people. And we can have those rovers scanning in Mars and scanning in the moon, and then we can all go to Mars in a pair of glasses without ever leaving the comfort of our own home. So I think there are a ton of disruptive things that are going to happen with virtual and augmented reality. And I'm really excited to see what you guys do with this technology. So thank you.
Checking that you're real.
We're not in the singularity yet.
Okay, as is in all the Forum 360s, you have submitted your questions online, and I'm going to now pose the questions to the panelists. So the first question is, it's difficult to see the disruptive business models behind the examples that were presented today. How are your organizations or businesses being disrupted by these disruptive business models? So I'll leave it open to anyone who wants to take on that question.
Well, I think one of the examples, maybe to give a tangible piece to this, is oftentimes we are unable to experience that disruption firsthand. A few months ago, I had the privilege of participating in a project for 3D printing sand casting molds. So I have a 14-month-old baby boy at home. He and I are on the sand business. We go to the beach every weekend and we build Disney-esque structures. I went to this foundry. There's a big sand pit, and there are people filling buckets of sand, building very complex molds, helicopter transmissions are the most intricate molds that we require from our suppliers, and there's big challenges with them. We showed up working with another company and had printed 20 blocks of sand that was bound by a binder through the 3D printing process, and in less than half a shift assembled the mold, which takes normally weeks to assemble. We then had the pot of molten magma come over and pour into the mold, and we got our casting. And a few days later, we decided we had made there was an improvement to be made. And within a matter of days, we reran the design model, the thermofluidodynamic model, the printing process, and showed up with another 20 Lego bricks and put this together. And I literally sat there watching the look on the people's faces around me who had just realized that their business model was shifting right in front of them. And I think that's the kind of thing that, while you're sitting here trying to explain how we're going to do that, it's very hard, but when you see it happen, it's very, very profound.
Thank you, Andy. Jack?
Yeah, I think I'll add to that. One of the fundamental things that's happening now is the emergence of the Internet of Things, not only in industry and in social media, but also now in the battle space for us. And so now, heretofore, there was a tremendous amount of emphasis on what the platform could do, what it could sense, how it could think, how it could create an effect. The transformation that's happening now is to begin to visualize that platform as simply one node amongst many, and that those nodes are not just in the air, they're in space, they're on the surface, they're on the sea, they're under the sea, and how to begin to link all those nodes together to be able to create collaborative effects in an environment where your adversary knows you're doing that and is attempting to insert themselves into that network and create adverse effects at the same time you're trying to create the ones you want. And that's a very different view of how to construct a deterrent force than what has happened before, and it is all driven by the digital transformation.
Thank you. Lenitra, would you like to comment?
I'm thinking within NASA, I didn't talk about some of the work that we're doing in additive manufacturing at NASA, specifically at Marshall Space Flight Center and in our engine development. And I agree with you is that in real time, while we're here, you really can't see the disruption. But when you're in the battlefield of developing technology, and we are trying to additively manufacture an upper stage engine using copper of a SLM process, and also trying to do an overcoat of EBF3, you're using two different processes with a material, that's disruptive, because now that's going to give us more thrust. We're going to analyze our ISP, and now it's NASA being in a position to say, hey, we're going to need this engine technology. We're going to need it in 6 months versus 2 years, and we are here partnering with industry to really forge ahead and try to get this disruptive technology out to industry so that we can buy it back, so that we're good stewards and developing these pathfinders. So that's one area that we really see the disruption is in our additive manufacturing of our engine parts. I think another area where we see disruption is in some of our in-space assembly. So many conversations of how do we validate it once we build it in space? How do we even start to assemble it? We for ISS, we manufactured these parts, these modules on the ground, and then we flew them up there, and then we assembled them together. But talking about actually assembling something in space, that's disruptive, and we're actually starting to talk that. We're not going to see that disruption for many, many years, but we have to really start analyzing how do we do it, and knowing that that's a disruptive technology.
Thank you. Brendan, would you like to comment on the AR, VR, and its impact in terms of disruptive business models, at least for aerospace and defense?
Sure, I think in the early days, not the further out future, AR and VR will be heavily used for training and simulation. We're seeing a number of companies in the aerospace and defense industry pick it up and use to do all kinds of training applications, whether it's for manufacturing, efficiency, building airplanes, and or it's actually for defense and going out and doing simulation of military operations. You can imagine you scan in a room scenario or a battlefield, and then you can go and you can do really advanced simulation and training of that. And I think that that's going to be very disruptive as the technology gets much, much better and much lower cost and smaller, lighter weight, which is going to happen just over the next few years. I think you'll see it be picked up kind of in mass scale and start making a real impact as it's more accessible and easier to use.
I think people want to know how soon are we going to get to the Iron Man character that Jack presented. You know, can we go and look at a part and say that part's going to fail in another few days here? But I think that's our sort of holy grail.
I think we'll get there quickly, but
okay.
It's 10 to 20 years.
Okay, very good. Another question that came from the audience, development times seem to be increasing, not decreasing, despite broad implementation of digital tools and methods. What are the main drivers, and don't say complexity? Jack.
I'll jump right on that one. I think one of the real challenges we face right now is our appetite for risk. I think that's one of the things that is driving unproductive time into the design process. In the DoD side, our adversaries don't have that same affliction. And if you look at the rate of innovation in the 40s and 50s when your grandfather was designing airplanes, we tried and failed fast. Right. And we had many airplanes ongoing at the same time with different jobs to do. And the idea was drive the innovation, try it, do the experiments with it. It may not all work. If 80% of it works, that's great. Fix the 20 that doesn't and press on from there. Versus getting in the mode of having 3,000 requirements and grinding in design to try to ensure before you even try it that all 3,000 requirements will be met. It takes a huge amount of time and cost. Versus let's try something quickly, let's find out what does work and what doesn't, we'll learn from that, and we'll be able to jump to an informed conclusion more rapidly. So I think part of the delay is in some circles there's a tremendous aversion to a failure of any kind, as opposed to a very educational and productive learning opportunity through a failure.
In conjunction with that, I think one of the challenges is the regulatory and certification environment we're in, coupled up with the risk element. And I think where you see a lot of this innovation nowadays, these smaller companies that are doing the electric vehicle and the Amazon style and drone delivery, who have not yet entered that certification market, but are doing that very rapid, many iterations developing. And I think the real risk to us as a community is how do we generate that next generation of engineers? If you look at your grandfather and people before you in the Skunk Works who are doing design cycles in years or 5-year steps, look at the 53K. By the time it goes to first unit equipped, we're going to be close to 2 decades. How does a company do that? We, Sikorsky, for example, are using some of our internal research and development, the S97, the X2, right? The X2 was internally funded a couple of years, and we have developed an entire generation of design engineers who've gone through that. So those, I think, are the 2 big challenges. How do you still certify and deliver the product, and how do you get the experience to learn?
And how you manage the risk, right, and not be as risk averse. So another question, kind of related, how have you integrated subcontractors in your digital design space? Do they all need to adopt your digital design tools, for example, CATIA, Pro-E, etc.? Do you feel this burdens your small business subcontractors from being innovative? So how are you managing your subcontractors in your digital environment?
I'll start off. One of the things that we did with the CATIA V5 and LCA is to actually bring the subcontractor into our design environment for that collaborative environment. But I think as a whole, the OEM contractor-subcontract relationship is always fraught with the trade of risk and responsibility. Early on in the design process, when funding's tight and the design space, the trade space is very open, you like to push design authority risk-taking onto the supply base. Inevitably, when the design synthesizes and comes into test and things don't work out, there's only so much leverage you have over the supply base. Ultimately, suppliers can walk away. Right? If it becomes unproductive for them to stay in the relationship, they can. So how do you nurture that? And so I think there's going to be a lot of rethinking of how strong those lines are drawn and how far you develop that technology and the relationship with the supply base.
I think from a NASA perspective, we've really figured out that we can do more by partnering and really getting our subcontractors and contractors engaged from the start. And one way we do that is through our SBIR, STTR program to really help with some of that early stage innovation and really working out how do you partner, how do you do those mechanisms of accelerating the technology and making sure that you have that common goal. But we also have fostered public-private partnerships, I know within STMD, where we really go to industry and say, hey, you may have this expertise, you may not have ever worked with NASA before, and we have this requirement. How can we work together? You may have a technology at a tipping point, or you may have a technology where you need our facilities or our expertise. And so we've really tried to foster those public-private partnerships and other mechanisms at our early stage to feed that pipeline and accelerate those technologies and get that digital thread and digital transformation within our technology.
Excellent. Jack, do you want to comment on this?
I would agree. It varies for us based on classification levels and how big the project is, but a project like F-35, where you've got design going on 24 hours a day around the world concurrently, the digital thread becomes absolutely critical to being able to maintain configuration control and make sure the teams are able to operate in a constructive, positive direction without having to have redo and corrected.
Using the same information.
Absolutely.
So Brendan, there's a question for you. Your virtual vision is not a world I would want to live in. What has been the response to this from the general public? Sounds like something that will be heavily exploited. Sorry to ask you the hard question.
Well, so far, the general public has embraced it and has gotten very excited about the promise of VR. We've been dreaming about, writing about, watching movies about VR for decades, and it's now finally, the time is upon us. It's starting to work. We're seeing a significant number of gamers adopt it, enthusiasts, and I believe that as people start to understand the technology and get more comfortable with it, they'll be adopting it. I think if you went back 100 years and showed people the smartphone and a glimpse of what the future was going to look like with everybody walking around staring at their smartphones, a lot of people would say, that's not a future I want to live in. But we're all here today, and we're all pretty happy with the world that we live in, and smartphones and computers have made a huge positive impact on the world and helped us do all kinds of things, including have better medical solutions for disease and live longer, and there's all kinds of impacts. And I believe that the virtual age and virtual and augmented reality will have an incredible positive impact on humanity in that same vein. So
Absolutely.
I think it'll all work out really well.
So let's do a poll. How many of you want to see a virtual avatar of yourself? So there's a few people.
You want your great-great-grandkids to be able to ask you questions.
Absolutely.
And talk to you and know what you were like, and I think a lot of us will want to live on in the future. And it's more so, I think, the younger generation. The younger generation that's growing up in a smartphone world where they're on their phone or their computer every day for many hours a day. They're very excited about the potential of not having it be a smartphone, but having it be a pair of glasses and having this kind of virtual superpower that we're going to be able to enable them with. So I think it's inevitable and very exciting.
Yeah, me too. Okay, another question. The panelists talked a lot about technical disruptions. I'd be curious to hear how digital advances can enable business process disruption in areas like partnering, contracting, intellectual property, lifecycle management and operations, knowledge capture, training and development, and many more. So how can other digital advances help these other areas like partnering, contracting? Right? Anyone take that on?
I'll start off. One area that I think that was touched on there that would be hugely beneficial is in kind of getting into being able to share between generations. as we bring new generations into our design force, how do they take advantage of what was learned 20 years ago, 30 years ago, 10 years ago, in the tremendous amount of IRAD work, internal research and development work that's done in the government labs, where very significant discoveries and realizations were realized and maybe meticulously documented, and they're buried 25 years behind us. And suddenly we come up to a point where, hey, I think I want to try this. I don't know if anybody's ever thought of that before. This is a really great idea. Right. And then how do we have an intelligent enough ability to be able to reach back and realize, hey, that was actually a tremendous amount of work was done at Langley 5 years ago. Here's this paper, and in the paper, here's the particular relevant element to what you're attempting to accomplish. Because as generations wash through, we don't want to lose all of that design DNA, history, and learning, right, and have it just be in paper form or in rudimentary searchable electronic form, but searchable with intuition, right, and ability for the autonomy in the machine to be able to put it in a form that is relevant to what the designer is attempting to do at the point of use.
I'd like to, go ahead. All right, one of the things that I think is the biggest challenge with expanding the digital interface in our development cycles to these kinds of things is the unintended consequence. No matter how well-intentioned something is, there's always a pitfall that we haven't thought about that later on becomes a complete project-ending example. I don't have a good example in the area of contracting, but I will share with you a little vignette I had this weekend. I was talking to a friend of mine who was extolling the virtues of the new car he bought, and he was incredibly excited about the very simple lane control that it had. So it could keep you in the lane if you set up for it. And I said, so that's pretty cool, but why do you need that? And he answered, he looked me in the face and said, so I can text easier. And that to me was really a shocking realization that he was excited about a technology that is meant to enhance our safety, but it was actually going to be used for something that really shouldn't be doing. So in the world of contracting, supplier management, those things, there's going to be these hidden unintended consequences that we have to be very, very sensitive to.
I know I've seen in several of our projects where we have partnered with external entities, and you mentioned IP, and there's always a question of, well, who owns the IP? And I know with some of our investments, we have really encouraged industry to say, they may come with a list of 20 things they want to protect, and we may come and say, hey, but we really need to make this open source. We really need to make this available to the external community so that we can, we don't have to go search for these informations, or we don't have to say, hey, there's not this design data book, so when we want to go and develop a new material, somebody else has done it, and we can start from that point of view. Now, as far as a digital transformation, I don't know if we're there yet, but there has been that conversation of being able to make these open source so that a wider community has access to these technology development. And I think another point is that for many of our technologies in our portfolio, we really try to get the project managers and the PIs who really, really just wants to move their technology to think about long term. When this project ends, we don't just want it to sit on the shelf. We want to mature it or infuse it. So let's come up with a manner, it'd be a design database or some type of electronic report that we can have for long-term use. So we've really tried to encourage our project PIs to think long-term of how do we digitally preserve what you've done.
I think one other comment about the IP is that there's also two levels that you can, to help, there's revealing that data is available, and then there's the magic.
Right.
And so you may want to be able to reveal that there is a process out there that has this great effect, and it is available from this supplier, or it is available to this supplier. But then you have to then have the necessary permissions in place to reveal
Exactly.
the IP beneath that.
So it's always a negotiation.
Yeah.
We think about one use case that we think about often for partners. We produce our hardware in China. We have a number of partners in Asia. And there's a really challenging language barrier and distance. Right. And so with VR, we're trying to reduce that distance, that physical distance, and really collapse it down to one space where we can jump into a space, a shared space together. Somebody could be in China, we could be in California, we could jump into a shared space, be face-to-face, communicate, have an auto translator that's translating, and if we have a virtual avatar of them that can lip map correctly to the translated audio, we could see a version of them actually speaking English or of us speaking Mandarin or any language. And I think that that's going to be able to bring us together in a really powerful way. And we talk about that often, about how do we get that collaboration, how do we solve that for that collaboration use case.
Yeah. It's an excellent example. I think we all have those challenges when we do business overseas in different countries in different languages. Let me give you an example that Dr. Attia gave this morning that some of you heard at the plenary. So we've all flown on aircraft, and we've all been in aircraft or operations delays at an airport. And you can imagine this scene, as Dr. Attia pointed out this morning, that a maintenance person comes onto the flight, and you're like, oh my God, I know that's a bad situation, right? Because the pilot never says exactly what the problem is, but it's some maintenance problem that usually costs you at least 3 hours before it's fixed. And the example that he gave was a simple bolt that was missing in the pilot's seat, and they didn't have that particular part at that particular airport. But if they had a 3D printer with the drawings for that particular part, they could have made it in minutes and put it in, and if it was certified, they could have taken off in 30 minutes instead of 3.5 hours. So that's a disruption using technology on a real situation. We haven't done that before, but I'm just saying that was an example that he gave where technology enables a rapid solution if throughout the supply chain and the certification and regulation chain that it was approved to use a 3D printer with the certified drawings for the particular part that was missing that allowed the maintenance person to install it in an aircraft. So do you see that happening in the future is the question. Something like that.
I think.
I see that happening in space because we have a 3D printer on the International Space Station, and our challenge is certifying those parts, right? So once we get over that hump, and the crew loses a wrench or they need to fix something and the part's not there, we're not going to go launch it. We're going to print it. Right. So so those are real conversations that we have right now.
How about a helicopter gearbox?
Yeah, so there's a digital thread here that goes through the process of recognizing the problem, transforming that into actionable instructions, and then doing the hands-on work. As an example, what we're doing at Sikorsky on the first two pieces, an offshore oil helicopter will take off in Aberdeen with 19 oil rig workers, and they'll be flying an hour into the North Atlantic Sea. Shortly after takeoff, something goes wrong on the helicopter. It's not an emergency that shows up on the cockpit's warning system, but it's important enough that something has to happen when they land. This data goes through a satellite to the Fleet Management Center. The incoming station on the oil rig will get that information 45 minutes before the aircraft arrives. It'll tell the maintainer, you need to pull this part, this maintenance manual, this and that. If the logistics problem is big enough, the operator can choose to then actually dispatch another aircraft to move the oil rig workers if they can't carry on flight. So in those first two pieces, yes. And then for the 3D printing part, which obviously in this forum here is a really desirable end state to have, but there are other more pragmatic solutions. For example, forward positioning of parts, warehousing of parts. The space station probably has a very big inventory of that. So I think instead of focusing purely on the end state, make sure that entire chain is well-defined and populated already.
I agree.
So I add a couple of thoughts. One, I can't minimize enough the certification challenge, which is very worth solving.
Right.
But all 3D printers are not created alike. They all create different crystalline structures in the way they produce the part. All that has to be considered in whether the part can be considered airworthy and whether it meets the certification requirement. And then in addition to having a certified drawing and a certified part, there has to be a certified process and printer that's got its inspections current and signed off by the certifying authority that this year, this month, this week, it produces parts that are certified. So with that overhead in place, you can print the part. Now, why would you want to do that? We've talked about the 3 hours versus 3 minutes at the airport. what if this is a weapon system that's been in the field for 30 years, and the last time we built this part was 30 years ago, and that whole generation is retired.
Right.
But we need this part now. If this information was available on how to print it and what the allowables are and what the certified process for printing it is, there was a story in the news here not too long ago about the B-1 Bomber Force was scouring the aviation museums for parts off of older B-1s they could put in the ones in the field because they couldn't get those parts anymore. Being able to sustain a weapon system well past the shutdown of the production line and the whole supply chain moving on to other things would be hugely beneficial using that capability.
Thank you, Jack.
Actually, I'll just add to that. I think that is one of the biggest challenges of our aerospace community. We are expected to be at the cutting edge of technology, driving new innovation, driving new processes to reduce cost, reduce lead time, add value to the customer, add value to our corporations. And when you then finish developing this wonderful machine, it's in the field forever. The S61 is 54 years and counting. And so I think part of the problem is how do you then manage that longevity of machines that fly a lot longer than the designers and the designers' children. And to some extent, 3D printing is an option there, but I think it's a larger topic than just the actual procurement of the part.
So a big question that the audience supposed to pose. In all of your presentations, they didn't hear very much about data integrity and or about security concerns. How are digitally transformed business models going to be secured in the future? Do we have to worry about this before we really lean in 100%? Anyone?
But
Right.
it is absolutely a huge issue, and as most folks who work in data security know now, you can't assume that you can actually build a fortress strong enough to prevent an insurgent from going in and messing with that data. You have to assume that they're inside your firewall with you. And so technologies like blockchain and other technologies that are coming along to help ensure integrity and identify where there has been corruption of data and isolate it are going to be critical to all of these constructs, whether it's the battle space use of the digital transformation or the design process or the business processes themselves.
Anyone else?
I think the all-in extends to both the business environment and the user environment. If we look at potentially another future state is really why should we worry about using lane-changing technologies or lane-holding technologies to text more? Why don't we just stop talking about driving and be in autonomous self-driving vehicles? And you need to have the customer buy fully in and have trust in the system that it will do what it needs to do safely. And this all-in from a security perspective is not just the data in your design environment, but the data in your execution environment.
So how do you see digital artifacts being shared between customers, corporations, and third parties? So how do you see the digital artifacts that sit on your design space being shared among your customers, corporations, and third parties?
I think that's probably one of our biggest challenges. As an American for-profit company, our entire definition of value derives from our intellectual property and our ability to use that to out-innovate the next generation and to safeguard the investment we've made in the past. We really enjoy working with the government, but we always have that healthy tension of more public domain or more pre-competitive domain work for what we have, and I think that's not going to get solved very quickly. There's a much larger business legal element to that than the pure technical element. In terms of pure technical sharing the information collaboratively, I think the framework is there and evolving. The gates that allow the information to flow really need to still be worked out.
Yeah.
I totally agree. I think it's always a negotiation, especially with dealing with the government agencies, of how to, from a NASA perspective, our goal is to disseminate that information out to the public and to industry and to academia so that we can accelerate technology and not only meet our goals but meet their goals. But then there's also challenges when we're dealing with international partners, we're dealing with industries who need to make a profit, so they need to look out for their IP. So there's always that negotiation of how do you do that, and then dealing with legal. And legal doesn't necessarily pay attention to digital transformation. They're looking at the bottom line.
They still
as
have
far-
yellow pads.
Exactly, right? So I don't think we've solved that problem, and we won't for a while. But it's a conversation. You're at the table, you have these partnership mechanisms, and you have that discussion with your partner.
What is the experience at Oculus?
So can you repeat the question?
So how do you see digital artifacts being shared between customers, corporations, and third parties? And I think to Jack's point, so let me make it more pointed for you. So if you create these virtual avatars of human beings, of Jack, of Lenitra, of Andy, where does the privacy come in? Does Jack own that avatar and all of his digital creation of his embodiment? Who owns it? Does he get right over whether you can use it or I can use it? So,
Well, we're going to find out. I think there'll be multiple attempts at different solutions, some that are centralized and some that are decentralized. I think most likely you're going to want to have control over your data.
Yeah.
It may be sitting in a company's system, but you'll have privacy control over
okay,
what
let me interrupt you for 1 second, because this happens to all of us now. And I just have to use this as an example because it's true. So when I fly into Heathrow Airport in London, they do an iris scan and they do a thumbprint. And I don't know where that data goes. All I know is I'm just trying to get into the country, right? And I'm not going to go through a big security situation. I just want to get into the country. But basically, that's my personal information. So there's some level of privacy. And that's just simple stuff, thumbprint, iris, right? So that's where I'm going with this. So, but right now we haven't even addressed that legally. Who owns the data?
But if you take that to it's a very analog early construct, our credit data, it's my data, right? I made the purchase, I applied for a bank account, I did this, that's my information. Somebody else is out there mining and gobbling that all up, packaging it, and there's a whole secondary and tertiary market out there. And on top of it, I'm allowed to pay to monitor it. I think the business models and the unintended consequences we talked about earlier here are going to be a very, very, I'm going to say pragmatic, exciting environment to understand how this is going to evolve.
But I do think the legal part of it has to catch up too, and it's way behind. It's way behind. We're not even talking about where you're going, but it's way behind on the simple things, right? So I just think that's another big issue that we have to resolve. Sorry, I interrupted you. I don't know if you want to still comment after all of that.
Well, we're thinking about this right now as we look at the next generation, future generations of VR devices and AR devices that have scanners, sensors that are scanning your eyes for understanding exactly where your eyes are looking and to deliver a better experience. And so now we're starting to get a lot of eye data, facial data, as well as the room that you're in. We're scanning that so we can show you where the room is so you don't bump into things. Scanning objects that are in your room, and we're looking at how to store that data, how to have privacy control around that data. So it's it's top of mind.
Right.
I'm confident that Facebook, Oculus, we're going to navigate it well, as we have navigated personal data well so far, well enough that most people are on Facebook, pretty comfortable with how.
So I think this next question is for Jack or Andy. You talked of what I would refer to as model-based design. Are you linking the requirements up front and the production system?
So I won't comment in extensive detail, but yes, we do have systems that have requirements, flow down and cascading. Goes from 1,000+ military requirements to hundreds of thousands of detailed design requirements, but we still generally separate the requirements from the actual design per se. There's a gate there. And then I think the model-based design, we're still learning. We've had some unintended consequences. We've had some pitfalls. I did cavalierly here state there's no drawings. One of those, there are a few drawings that the vendor doesn't know what to do with the model, and you have to actually print out the 3 orthographic views. So I think we're in that process of having taken the big plunge and say we're going to do this, and then there's a lot of cleanup and learning for the next generation.
Chad?
It's a very fruitful domain, though, because we have just gone through an experience. In fact, the proposal was just submitted, but we're in a competition right now where the customer, in an effort to remain on track with what's happening with an evolving threat, to protect the competition, I'm going to change what it was for, initially came to us and said, I want to have an off-road SUV with monster tires on it. And we busily designed that. Then came back and said, actually what I need is an Autobahn cruiser. I want it to do really well as an Autobahn cruiser. And then, with a short amount of time remaining to issuing the proposal, the requirement became, I want a pickup truck. And by the way, I'm not going to give you any credit for your off-road performance or your Autobahn performance. None of that will count. So we had done a tremendous amount of design work in both of these other areas and had to shift to a new design point. There was a straightforward conventional path we could take, and then there was also kind of a dark horse radical idea that was also on the table, and we had a short amount of time. And had we not had the design tools necessary, we probably would have just singled up on the low risk path and gone with that. But we had enough ability to design quickly enough to run the dark horse also. And at the end of the day, it turned out that the more radical approach was almost 3 tons lighter, had almost 3 hours more endurance, which was a requirement, and was cheaper to produce with less parts. And without the digital transformation design tools available, we would never have been able to, one, shift horses off of our other designs that fast, do a design that was right on top of a new set of requirements that came late, and be able to run 2 competing designs to find out that the radical one was the better of the 2 without having progressed to the point we have so far with digital transformation in the design.
Great, thank you. So we're getting close to the end of our panel session, and I'm going to give you guys an opportunity to have some final remarks about anything you would like to say about where you see the digital disruption moving and what your colleagues in the audience should embrace going forward. So, Andy, I'm going to turn it over to you first, but get the others a little bit more time to think about it. So this entire transformation that we're seeing with digitization, the digital twin, the use of the cloud, secure computing, and it's enabling these new ways of doing business for aerospace and defense. What would you say to your colleagues about what they should think about how to embrace it going forward?
I think in this context, with actually not getting into the details of these particular nuances and topics, what I think the most important thing that we can do as individuals and as a business and as a larger society is to actually take the past as a prelude to the future. There have been many transformative periods, and along that way, there have been many successes that are typically lauded very highly, but there have also been some very notable failures, not notable for the fact that they failed, but notable that we should learn from them. And I'll give you an example. This past weekend, I read a very fascinating article in the public press titled, "Why Was the Beech Starship Such a Failure?" So this was an aircraft designed in the late 70s, 80s. It was, Beech had got the King Air as a really dominant market turboprop, and Beech decided to go into the turbofan or into the turbojet business and designed a swept-wing, all-composite Canard aircraft. From an engineer's perspective, an aerospace engineer, this was, brilliant. It had all the features that anybody could ever want, and they only ended up building 50 of them and then bought them back. If you have time, I certainly encourage you to read that article. But the takeaway from that is we really need to understand what happened with companies and ideas and systems that succeeded and those that didn't. To use the Oculus as a bookmark here, that digital age that we came up with in the late 90s, that MySpace and the Mozilla Firefox and Netscape, and what was the browser, Netscape, right? Mm-hmm. All those things. Why did we end up with the products we have now? Right. What are those that didn't make it? Or Betamax, mm-hmm. Right? So I think that's really something we should really keep in mind as we then apply this with these very specific tactical things that we're struggling with.
Thank you. Lunitra.
I always think about my 6-year-old son, and I always tell my husband, we're really savvy in how to use the iPhones and how to use iPads and all this other technology and digital platforms. But I always think about, well, what is he going to have? And he's going to say, Mom, you don't understand. Because as a 6-year-old, he can use the iPad better than most adults. And so I use him and I look at him, and very similar to what you said as far as the virtual reality is, we have to think about who our future engineers and our future scientists will be, we will not be doing the same things we're doing now. We really have to think out of the box and bring technology development and bring the digital platform to a point where the younger generation is going to understand it, and they're going to continue to accelerate it and push it to a point where, you know, we're going to be, you know, gray-haired and not know how to use it. But we have entities right now thinking out of the box, doing cutting-edge development, and really just making the impossible possible. I don't think, you know, when you look at entities like SpaceX or Blue Origin or other entities, they're really thinking out of the box, or Oculus, and we need to do that because the next generation's not going to go read a 30-page manual. They're going to ask artificial intelligence. Hey, you know, they're going to be talking to artificial intelligence. So that's kind of where we need to be thinking.
Jack.
I completely agree, and I do believe that the crucible that determines what of this sticks and what doesn't is what happens at what I would call the tactical edge of design. So you have tactical edge in a battle space where the effects are actually happening. In design, it's where the designer is at the console making best decisions, or at the virtual interface in the future. And either it is an aid to the designer or it's not. It's either speeding up the process and it's lowering the cost, or it's not. And if it's not, it's going to get pushed aside. And those constructs that do aid the designer in moving faster and making better decisions quicker are going to have the edge and be the ones that are picked up. Because again, at the end of the day, the tools are only as good as the talent that wields it, and the talent will decide what is helping them be faster and be cheaper going forward. So one of the key things that we see as we look at autonomy, whether it's in the weapon system or in the design process, is it making the human better? We don't want to replace the human, because that's where the discriminators are often coming from. We want to augment and enhance the human, not replace them.
Okay. Brendan.
I would go back to the question that you asked earlier on, is this a world we want to live in or not?
Right.
I think that usually comes from someone who hasn't tried an Oculus Rift.
Right.
A lot of times when I hear, oh yeah, but is it really going to work, or you know, is it any good? I don't think I would want it. They haven't tried the Rift, and as soon as we put them in, and then they come out of it, they're filled with ideas.
Right.
Everybody has an idea, which
Right.
is one of the most exciting things I've ever seen. You know, if you give somebody an iPad, they don't give it back to you going, God, I got so many ideas. Right. But if you put them in VR, as soon as they take off the headset, they have so many ideas. And I think my point would just be to encourage everybody, before you doubt it, try it.
Great recommendations. Let's thank our panelists for their comments today. Come up and this concludes our panel session. Thanks for being here. Appreciate it.
Thank you, Daryl.